And the way that we can calculate that is by doing the integral, the definite integral from a to b of v of t. And I thought that I would show you a couple different ways of approaching this. What if we looked at it from this perspective with v of t being rewritten as x prime? So definite integral from a to b of x prime would be the same thing as the definite integral from a to b of v, right? X being like kind of a position function. So if you think about it like this, what's the interaction between the integral and x prime? Like what happens when we actually complete that process? Yeah, they cancel each other out, right? Yeah, so this would give you x of t evaluated from a to b, which would be, using FTC1, x of b minus x of a. So maybe you can see that displacement coming through a little more clearly, right? Instead of just like a memorized thing, you can say, look, it's the position at b minus the position at a, and if there's a difference there, then the displacements would be something other than 0. If x of b and x of a are the same, the displacement would be 0. I also like to look at it in terms of a graph. So if you look at a velocity graph right here, and you have a and b right there, you know, who knows what this graph could look like? Like your graph for today might look like this, right? This would be you traveling to school, right? And then this would be you going back home. And so your displacement for the day in this case would be 0, right? And I know it's not a perfect drawing, but those two areas are supposed to be roughly the same, right? Just different size. Yeah, Lenny, go ahead.
If you slept on like one side of your bed and you slept on the other side.
Yeah, totally true. Maybe your displacement would be like 1 foot or something, 2 feet maybe. Yeah, depends on how big your bed is, right? If you got like the California King, it could be like 6 feet, right? Yeah. I'll tell you what, for me, like I'm one of those like kind of wild sleepers, I guess. Like I'm all over the place, so I like might have some serious total distance traveled, you know, during the night. My wife, man, she ends up like diagonally twisted, and the sheets are all like wrapped around her, and I wake up in the middle of the night, and I'm like cold, you know. So yeah, it's possible. We could, you know, a little creepy if someone was like keeping track of all that, but you know, yeah. Wouldn't that be the worst? Someone watching you sleep. That's kind of the ultimate creepiness. Yeah. So I don't have that problem. I just sleep through the night. Never have an issue with that. But, you know, you could have all kinds of other things. You could have displacement that does this. What kind of displacement would you call that graph?
Displacement?
Yeah, what kind of displacement? I don't think it's 0. Well, because this area is a lot bigger than that area.
It's going to be positive.
Positive displacement, right? So this means you are, you know, further to the right of where you were to begin the day, something like that. And then, of course, if you had a velocity graph that looked like this, you know, and something like that, then, of course, your displacement in your position in the end really would be further to the left of where you started, because your displacement overall would be negative, because the area that's below is a lot bigger than the area that's above. Okay. And then to compare that, of course, with total distance traveled, distance does not take into account left and right or up or down. It just counts that you moved, right? And so the formula for total distance traveled, of course, is the definite integral of the absolute value of v of t, you know, from a to b. I don't have a good way of looking at it from like that perspective, but I will look at it from a graph perspective. If you have a velocity graph, like before, and let's say the velocity graph does, I don't know, something like this, and there's a little bit of left movement. You'd look at this and say, well, the displacement would be, you know, that positive area plus the negative area, right? So positive something minus whatever. But if we were to change this up a little bit, we were more interested in total distance traveled. Our velocity graph would maybe still look like this, but then we would also, to get the total distance traveled, we would want to consider this graph, absolute value of velocity, also known as, well, no, the absolute value of velocity, speed, yeah. So wouldn't the absolute value of velocity, wouldn't it look exactly the same as the velocity graph, wherever velocity was positive? But then wherever velocity was negative, you would get that reflection upwards. What used to give you negative accumulation now would give you positive accumulation. And so if we look at the classic, you know, zero displacement graph, so if we look at this one, the one that we hope is your day, we'd say, hey, your displacement overall is roughly 0. Well, the total distance traveled then wouldn't be 0. We can clearly see that you moved. The speed graph would look the same there, but then that loop that was down below would be reflected up, accumulating positives the whole time, so your total distance traveled would be positive whatever. Make sense? I just want to kind of explain why that is. I think graphs are kind of a handy way of looking at that. Okay. So with that in mind, why don't we take a look at example number 2. I'll give you guys a chance to run through this on your own, kind of together. You get 2 questions there. Let's try them out. Integral from 1 to 5 of v of t. And if you keep in mind that you are definitely allowed to do something like that, right? You can just put the name in there. You don't have to list out this long, expression like that. You just put v of t because that's what v of t is. Did you use Math 9?
Yeah.
I didn't know if you were or weren't. I didn't say you could or couldn't. I just thought, let's try it.
The absolute value one I did, but the first one.
Oh, and then you plugged in? Okay.
Yeah, I found the position function.
Okay.
Quite difficult.
Well, you'd need some kind of a initial condition to get your C. So when you did Math 9 or you did it by hand or whatever it is you did, what'd you get for 10 2/3? So 10.6 repeating, I guess. Okay, do you guys agree with that? What kind of units would go with that? Feet. Okay, that makes sense, right? Based on the feet per second there. Okay, so then for total distance traveled, integral from 1 to 5 of absolute value of v of t would equal, maybe you did Math 9 again. I think that would be very wise in this case, right? Otherwise, you'd have to piecewise it out. Very doable, just would take a while. What'd you get for this one?
11.833.
Okay, so 11 5/8 it sounds like. No, 5/6. 5/6. There we go. Okay, so feet. Okay, so I know you can push the buttons to get Math 9 and blah, blah, blah. That's great. Hopefully you got good numbers. I want to maybe take it one step further, though. Let's talk about this. Based on just those numbers alone, what can you assume about the particle? Yeah. Didn't it have to turn around?
Yeah.
So if those 2 numbers were the same, then we know that it went one direction only.
Right.
But if those 2 numbers are different, then it at least turned around once. Maybe more than once, but at least once for sure, just because they're different. Okay, fantastic. Very, very good. Okay, I think the next one is about your calculator. Yes, it is. Okay, so you already know this, so that's great. I would say that this one, I would normally maybe give you a little more direction, but since you all are comfortable with Math 9, that's fantastic. Let's see if you can do this one. I'll just throw it at you. I was going to kind of scaffold it a little bit more, but since you already have the calculator part down, let's see if you can set it up. Work together, and certainly fill in the blanks for you here in a second, but try it out. Look at that. Really like this question because it allows you to do the complete FTC 1 and 2 really. So what I would do with this one, hopefully you did something similar. I'd set it up like this. Integral from 1 to 5 of f prime of x. Oh, you know what? That should be f prime of t. Sorry for the typo there. It should be f prime of t. So f prime of t dt is equal to f of 5 minus f of 1. What I'm doing there is I'm doing fundamental theorem 2 by saying the integral or the antiderivative of derivative cancel each other out, and then FTC 1 by doing the difference in the antiderivatives. So we know, of course, that f of 1 is 3, so f of 5 is right here, minus 3 right there. And then we get this integral from 1 to 5 of root log t dt. And of course, that root log t is not a very friendly integrand. It's not something we're going to be able to just figure out the antiderivative of. And so what would we do to evaluate the left-hand side? Got to do Math 9, right? That's the most efficient way. Since the calculator is active, you've got to do that. Once you do Math 9, don't you just go plus 3 to both sides? And it's all over. So what'd you get when you did that?
5.5614.
5.5614 equals f of 5. You guys agree with that number? Did you guys set it up similarly? It might have had a few details that are a little different. Do you have any questions about the best way to do it? Maybe you have a way that you like better. I don't know. That's okay? All right, well, let's dive into some, hopefully, very fun application-y stuff. Here we go. So this first one, I don't know, a little dry, I guess. We'll get to the gravel later, I guess. Yeah, we got a good gravel one. But yeah, so this one right here, let's do this. I'm trying to think. I picked one that didn't have a tank for you guys, right? No tanks of water or gasoline or anything like that. Just a pile of gravel. We say the gravel's in a tank, right? We'll say that. What's that?
I don't think there's actually a difference.
There really is no difference, right? It's just either contained in a tank or it's just a pile on the ground. But yeah. Anyway, so let's take a look at this one here first. This is you can clearly see this is a free response questions from a past AP test. Gives us this graph of f prime. That's a really important thing to note. There it is, graph of f prime. It tells you that it's a semicircle and lines, piecewise linear and all that stuff. And then it asks you a bunch of questions. So I have a lot of faith in you guys. I think you could probably do really good with this. Give it a shot. We'll check answers in a little bit and just kind of see. We might skip ahead to the gravel question after this. I don't know. I'll give you like 10, 12 minutes to give this one a try and see how it goes. Feel free to work together, compare answers. I'm going to do part A up here, and let's just kind of compare our answers, see how it goes. So it says find the values of f of -6 and f of 5. So those are the endpoints, aren't they? Those are the endpoints. Of course, the kind of the crux of this, like the real turning point for us, is going to be the fact that we have a graph of f prime. We have a little information about f, but then they asked us about f, right? So since they gave us a lot of info about f prime and they asked us about f, what is going to have to be a part of our strategy here? Got to do some kind of an integral, right? Yeah. So you could conceivably, possibly, I don't know, you might be able to treat this like an indefinite integral with a c and then do some work and find the c, possibly, although that might fall apart in some cases. I think it's going to be easier to do a definite integral and think of this as an accumulation process towards whatever value we want. So, so starting this one off, I'm going to say integral from -6 to -2 of f prime of x dx. Why would I pick those limits of integration?
You know -2.
Yep, I know about f of -2, and I want to know about f of -6. So I'm going to just put equals, and I'll put f of -2 minus f of -6, and there we go. So I know that f of -2 is 7, so this is going to be 7 minus f of -6. But then how am I supposed to evaluate that integral on the left? Use areas. Now I have seen all kinds of stuff. I think I shared this with you before. I have seen folks saying, okay, so we're going to integrate from -6 to -2. And so instead of just looking at areas, they try to figure out the equation of that line. Right? It is a line, so it's not that hard to do. They try to figure out the equation of the line, then they find an antiderivative, then they do FTC 1, subtract, and they find it. And it's like very possible to do that. But isn't it a lot easier just to be like, it's a triangle. Find the area, right? It's a lot easier to do that. So if we do take that route, there's the little triangle stretching from -6 to -2, and it's what, 4 by 2? And so the area would be 4. So 4 is right there. You subtract that over. Do you guys get 3 for f of -6? Does that work? Okay, good deal. Well, then I'm going to move over here for the other part of A, continued. So this one would be trying to find f of 5. So this time it's going to be the integral from -2 to 5 of f prime. And that's going to equal f of 5 minus f of -2, using the same kind of strategy we did before. Once again, I know that f of -2 is 7. F of 5 is my target. And then finding the area here is a little more challenging, right? Because you've got this circle involved. And so this is where people, unfortunately, will really do some unfortunate things. They'll figure out the equation for the circle there. Again, not that hard. But then they end up trying to do an integral with that, and it gets really difficult because of the square root, and they get all stuck, and they're like, what do I do? Or you could just say, it's a circle or a half circle. Let's find the area of it. And it makes it a lot easier. Of course, this is a triangle. So let's see here. The radius is 2. So the whole circle would be 4 pi. So half the circle would be 2 pi, right? It is below the x-axis, so it's going to integrate or accumulate as negatives. So we'll put negative 2 pi, and then the little triangle is 3 by 2. And so the area there would be 3, so plus 3, you add 7 over, you get 10 minus 2 pi is equal to f of 5. Okay, so is this good confirmation for you? You're good? You got it? I'm seeing confident faces. Beautiful. Okay, so then B, this actually has nothing to do with this chapter, but I think it's great review. We should always be just like weaving review in, and so that's kind of the purpose of B. On what intervals is f increasing? So what did you say? Let's just throw it in here. F is increasing on which interval? Or you know what? It does give it away. There's more than one, right?
-6
-6 to -2 and
2 to 5.
2 to 5. Okay, so we'll just list those intervals out there. -6 to -2 and 2 to 5. Okay, and then it does say justify your answer. What's your reasoning there?
F prime is greater than 0.
F prime is positive. Yep, there you go. So F prime greater than 0 on those intervals. Okay, so good memories from back in chapter 3. Yes? Solid? Good? Okay, beautiful. C, this goes back into chapter 4 a little bit. C says, find the absolute minimum of f on the closed interval -6 to 5. This is a combination of 3 and 4 a little bit, right? It does use the magic word absolute or global minimum. So we're talking about not just interior candidates, but also endpoints, right? Yeah, the ones on the very edge, the exterior candidates. And I imagine we've probably done some nice work leading up to this that'll help this question be a little bit easier. But I think it's always a good idea to list out all of our candidates just to make sure that we cover everything. So our candidates would be the two endpoints, so -6 and 5. And what else? -2 and 2, right? The two ends of the little semicircle, right? Okay, so the endpoints are -6 and 5. What are -2 and 2? Like, why did you pick those? Critical numbers, right? It's where f prime is 0. Yep, that's right. And so it's kind of the typical way, I suppose, to evaluate these absolute mins and maxes is to do a table. You can use some reasoning to eliminate some parts of the table, but this is a way to do it. I usually do it in order just to make sure I don't forget something, like so. And I think, the good news is we already have 3 of the 4, don't we?
Yes.
Right? So we already figured out that f of -6 is 3. And we know that f of -2 is 7 from the question stem. And we also figured out f of 5 is 10 minus 2 pi. So as far as actual real work that we need to do, it's, sorry, that's kind of getting crowded down there, is finding out f of 2, right? So what do you propose? What could we do to find f of 2? Or is f of 2 even a real candidate for the absolute minimum? Or is it kind of like a red herring, or like a not a realistic candidate? It's a real candidate, right? Because what's going on at 2?
Goes from negative to positive.
F prime goes from negative to positive, meaning that it's a relative minimum, right?
Mm-hmm.
Meaning that it is a possible absolute minimum. If you looked at -2, couldn't we have maybe written a statement about -2 and said, hey, that's where f prime goes from positive to negative?
So it's relative maximum.
There's no way it could be the absolute minimum, right? It's a relative max. No way that's the absolute min. But we can list it out in the table there because we already have it. I think it's less work to do the table here. So yeah, suggestions on what we could do with finding f of 2?
What we did in A.
Yeah, just do the same thing, right? Yeah, right. So integral from -2 to 2 of f prime is equal to f of 2 minus f of -2. We know that f of -2 is the 7. There we go. F of 2 is what we want. And then when we evaluate that integral for the third time, for goodness sake, let's just do area, right? And it's what?
Negative.
-2 pi, right? The area is 2 pi, but we'll integrate that as negative since the area is below the x-axis. So I'm getting 7 minus 2 pi. So this is where we got I don't know, I think this was a no calculator question if I remember right. I don't remember, but I would bet it was. So how are we supposed to differentiate between which one is the lowest?
Because, 2 pi is like
pi is like
No,
at least 6.
6.28.
The 2 pi's are the same 2 pi, right?
6 reading.
So one of them is 7 minus, the other one is 10 minus. So yeah, so 2 pi is like, yeah, 6.28 something or other. So 7 minus that would just be a little bit less than 1, so which clearly is less than 3, less than 7, and definitely 3 less than whatever 10 minus 2 pi is. So I would say that we have our minimum, our absolute minimum, at 7 minus 2 pi. So I'll just write that down here. Oops. Absolute min. Okay, so it says find the absolute min. I would say the absolute min, we could just write it as 7 minus 2 pi. When they ask for the absolute min, they want the y value. If they ask where the absolute min happens, that's an x value, right? Usually they'll let you get away if you just put the ordered pair. They'll just like, okay, we're fine with that. Technically, we probably should just put 7 minus 2 pi for the absolute min. Okay, you guys look super calm, which makes me super encouraged. Yes?
Super calm.
Awesome.
Super duper.
Awesome. Okay, so then for D, it says for each of f double prime of negative 5 and f double prime of 3, find what they are or explain why it doesn't exist. I'm going to just erase C here since we just did that. What do you think about f double prime of negative 5?
Just find the slope.
Find the slope, yeah. So f double prime would be the slope of f prime. And so what is the slope of that line right there?
-1/2.
Yep, down to right 4, -1/2. Yeah, so notice it doesn't say about justifying or necessarily even really showing your work. So I think we could pretty safely just put f double prime of negative 5 equals -1/2, and we call it good, probably worth 1 point. F double prime of 3 does not exist. I agree with that. So f double prime of 3 does not exist. And this is, I think, this is where the real challenge comes in on the explain why it does not exist.
F prime is not differentiable.
Yeah,
And x equals 3.
f prime is not differentiable. So I'm trying to think about this. I think this might have been on last year's AB test. Like, I think this is a question from last year's AB test, or it's in the last couple of years. They take a pretty wide variety of, at least last year they did, I don't know, can't say for sure about this year. They took a pretty wide variety of answers as far as the justification. Can I show you a good justification?
Yeah.
Okay, so I would say something like this. I'll just I'll try to squeeze the justification in over here. If we said something like, it would be the limit as x approaches 3 from the left of f prime of x minus f prime of 3 over x minus 3 equals, so this would be, I'm basically expressing the derivative from the left of 3. So let's see here. From the left, I'm seeing a slope there of 2. I'm looking at this right here. Make sense? Slope of 2? Okay, so I'm going to say from the left, f double prime is approaching a value of 2. And I'm going to say then the limit as x approaches 3 from the right of the exact same difference quotient, blah, blah, blah. From the right, it's a little bit different, isn't it? Or it's a lot different. What do you see there from the right? It's linear, yeah. So it looks like it's down 2, right 2. I'm looking at the slope of that part.
Yeah.
So -1. And so I think I can squeeze this in here and say those two things are not equal to each other, right?
Yep.
Oh man, I'm sorry, I kind of got into the top of the board there. Since the derivative from the left is not equal to the derivative from the right, we could say it's not differentiable. Like that would be good reasoning. And that would be like the best reasoning, like textbook type reasoning. I will say this last year, whether it was this question or one similar to it, they did take a wide variety of things. Like if somebody said it's a sharp point, they took that. I should bring in my list of acceptable answers. Sharp point was okay.
It's not differentiable.
Corner was another one. Now, is not differentiable was not accepted. They thought that was circular because you're saying, hey, the derivative doesn't exist because
Oh, yeah.
the derivative doesn't exist, right? It's like kind of a circular reasoning there. There was a wide variety of things they did take. I was kind of surprised at how nice they were. It was funny. There was one that everybody laughed about that I saw once, and I think somebody else saw it too. We must have been grading the same school's papers, but somebody said, hey, you know, whatever it is, such and such is not differentiable at this point because that point is a doink point. D-O-I-N-K, yeah, doink point. And so I think what was going on there, the teacher must have had some little, like, they must have been like, and it goes doink, and like that's what they took away from that. So they didn't take doink point because nobody knows what that is. But we all got a good laugh out of it. Stop telling them it's a doink point, right? You know?
The teacher will never know.
Yeah, because you don't get the details back.
The details back.
Yep, that is unfortunate. I would love to hear those kinds of things. Hey, so let's do this one here. We've got, I don't know, let's do as much of this one as we can. I guess we'll save the gravel pit for tomorrow. So this says the graph of the function shown above. You've got, again, semicircles and line segments. But this is this might look like it's the same question, but it's a little different because g is defined as an accumulation function. And it says g of x equals the integral from -3 to x of f of t. So this is a little different. It has a lot of the same concepts, but it is a little different. So I thought we would do this one. I'll give you some time here. We'll do as much of it as we can before we go. I gave us a little more space here. To find g of 0, we're given a function for it. We're given a rule for it. G of 0 would equal integral from -3 to 0 of f of t dt. And so to evaluate that integral from -3 to 0, that's an accumulation, right? We could just accumulate the area. We definitely don't want to try to figure out what all those functions are. So if we do this, integral from -3 to 0, did you guys get 4.5?
Yes.
Okay, so we would just say equals 4.5. There's no need to do FTC 2 or 1 here. Simply g of x is that accumulation function. So then if you're going to find g prime of 0, what do you have to find first? Yeah, you have to use FTC2, but what are you finding when you use FTC2? Say again? No, not directly. So I'm just speaking more in general. If you're going to find g prime of 0, what do you have to find in the step before that? You got to find g prime of x first, right? So the ordering is you find g prime of x and then you plug in the 0, right? The ordering is quite important. So we find g prime of x, and to find g prime of x, this is where that FTC2 comes in, right? Because you're differentiating the left side and the right side. So g prime of x just ends up equaling f of x. So then g prime of 0 would equal f of 0, and f of 0 is 1. Yes, make sense? Okay. So did you guys get all the way done, or did you get done with like C maybe? D, C?
I did A, B, D.
Okay, so maybe what we'll do is next time we'll do one of them. Maybe you got one of them left, and then we'll go through the rest of it. Then we'll get to the gravel one, and then we'll move on. There is a 4.5 video. 4.5 is